Hi, everyone. Welcome back. Azure Cosmos DB live TV, episode 11. This is 11 weeks I've been running this podcast, and love to welcome back Thomas Weiss. Hi, Thomas. How are you?
Hi, Mark. I'm great. Thanks.
Good. So, everyone, this week we're going to talk about security, a very important topic, particularly for a database that has an endpoint out on the public internet. Being able to secure your database should be pretty much job number 2, I guess, maybe after you provision it. But it's definitely up there in terms of importance. And Thomas is the program manager for a lot of our security features for Cosmos DB. So I wanted to invite him back on. And we're going to talk about a few of these things today. So Thomas, good to see you again.
Yeah, absolutely. Same here, Mark. Great to be once again on the show. And to the point you just made, security obviously is important. Network security is a core part of all the security mechanisms that are available on Azure services. I wanted to start this session by just reiterating how important network security is. And as you just mentioned, I'm working on a lot of security features on Cosmos DB, and many times I have Cosmos DB users reaching out to me, asking me, "Hey, what's the least I can do in order to have good security coverage on my Cosmos DB account?" And the answer to that question is network security. That's the baseline. We should always remember that network security, things like IP Firewall, virtual network integration, those things are on the front line of any kind of security mechanisms. You can think about fancy things like custom access control, custom roles to better filter who can do what on your database. But the root level of security here is network security, because with network security you can prevent any unauthorized client to even connect to your database. So that should always be the third thing to think about. When you think about the
if you can't reach the endpoint, you can't hack it.
Right. And I would say that, I don't know, probably more than 90% of the security threats you could think about, in terms of running a workload in production, can be addressed with network security.
Yep.
Right. It's the front line.
It's the defense in depth, right? I mean, you need to have secure passwords, but the network should be part of that larger whole in terms of securing your data and securing your assets in the cloud. So
and it's all the more important because, as you also mentioned, Cosmos DB is a cloud database, right? We are an Azure service, and Azure is a public cloud. And what happens whenever you create a new Cosmos DB account? By default, from the beginning, that account, the endpoints in front of that account are going to be available to anyone, right? Yep. And any client on the internet can access your Cosmos DB account, which is fine as a default, right? And I think it would be counterproductive to enforce very strong network security from the beginning. For people getting started, it's a nice thing to have, and it's convenient to be able to access your account from anywhere. But certainly, when you are considering actually running your account in a production environment, probably trying to host production data and things that are becoming sensitive and mission critical, that's the moment when you need to think about network security and
agreed.
How you can reinforce that. Cosmos DB actually exposes multiple ways to enforce network security, and the first one, maybe the most basic but still very powerful, is that IP Firewall that we are embedding in Cosmos DB. And to enable the IP Firewall on a Cosmos DB account, it's actually very easy. And also, I want to say, for some people, maybe, especially if you are a developer, getting started with Cosmos DB, network security maybe sounds daunting, maybe it sounds complicated. It's not, right? It's really easy to set up some basic rules to make sure that you tighten the access control to your Cosmos DB account. And so what you would typically do on that account is to go to that firewall and virtual network section here on the left, and this is where you can see that by default, anything and anyone can access your Cosmos DB account by default after it has been created. But you can flip the switch to selected networks. And this is where you will be able to say, look, as a first step, I want to filter the IP addresses that are able to reach and to connect to my Cosmos DB account. And so once you flip that switch, here you just have to add all the IP addresses that you want to allow to access your account, and that's pretty much it.
Yeah, I mean, and I like how we make it easy so you can add your current IP from right there as well,
yes,
right? So,
yes, yeah, that's a little shortcut. We detect your current IP, and so if you want to make sure that from that machine where you are working on right now, you want to continue being able to access the Cosmos DB data plane, that's a nice shortcut.
You want to talk about the exceptions there below that?
Yeah.
Like accept connections from public Azure data centers.
Right. So a couple of a couple of them that we provide as a convenience. The one at the bottom is checked on by default because most likely you want that to be available. So that checkbox will make sure that the Azure portal still have access to your account, right? And whenever you use the Azure portal in order to browse your data, configure your account, etc., this is the checkbox to tick. The second one is a bit different. The second one will make sure that in terms of allow list and the range of IPs that will be allowed to connect to your Cosmos DB account, we will include automatically any IP from any service running in an Azure data center.
Yeah, because you're going to use like some app or some whatever that's going to run on a compute, like it's web apps or functions or VMs, right? So it needs to connect, obviously, because nobody creates a database and just let it sit there, right? So
with no compute, absolutely. One word about that little checkbox to really make sure our viewers understand what that thing does. It's really going to whitelist or add to the allow list any IP from any of our public data centers, right? Yep. So what that means, and this is kind of a side effect to take into account, what that means that any other Azure customer that is running, let's say, a VM in Azure would be in that allow list.
Yeah.
That doesn't mean that we only accept connections from Microsoft services or other PaaS services. That means that really any machine, any server running in Azure would be added to that list and would be allowed to access your account.
Yeah.
Now, I assume the concept of an IP firewall is probably easy to understand, but you know me, I never resist the opportunity to design fancy PowerPoint animations. So basically, the idea behind that IP firewall is that I have my Cosmos DB account here with my endpoint. I have two different clients running, in different parts of Azure or the internet. Each client has a different IP address, and by default, when the IP firewall is not enabled, any client is allowed to issue requests against the Cosmos DB. Whether that request will be processed and accepted or not, that's a different question, right? This is about actual access control. But in terms of physical connection to your Cosmos DB account, any client will be allowed. Now, if you put that IP firewall that again is kind of embedded in Cosmos DB, you can specify, for example, that only that 24.18.207.140 is allowed, so that client will still be able to issue requests, and those requests will be processed. Any other client will be blocked by the firewall, right? And this will be an active blocking being done at the Cosmos DB level. So let me switch back here to, actually I have lost my mouse. Oh, here it is. Let me switch back to the portal. So this is probably the most basic way to add some access control down to the physical level. Right? Obviously, what comes with that is that you need to know the actual IP addresses that you want to add to that allow list. Right? And you probably need to maintain a list of which are the clients that you want to be able to connect to your Cosmos DB account. Another way to do that is to leverage virtual networks. Yeah. By leveraging virtual networks, actually, you don't have really to care about what's the IP address of my client. Here, the assumption is that we will only allow clients from specific virtual networks to connect to your Cosmos DB account. Okay. And so, actually, if I briefly switch back to my little animation, the difference here is that if I have an application running in a virtual network and I want anything in that virtual network, any application, any compute, any service running in that VNET to be available to my Cosmos DB account, the other thing that we can use is what's called service endpoints. And basically, what service endpoints do is that they create that kind of virtual tunnel. I shouldn't call it a tunnel because in network security, tunnel has another meaning. But it's a way to automatically allow anything that is running in that VNet to connect to my Cosmos DB account. Okay. And so setting up service endpoints, again, is really easy. You can set it on an existing account. Okay, so here, if I go up, we have that virtual network section of my, whoops, sorry for that. That the virtual network section of my firewall and virtual networks sub-menu here. And this is where you can either add an existing VNet or add a new VNet. Okay. And this is really a one-step process. You just select which VNet you want. Also, obviously, you need to select which subnet you want to address. You click add, and that's it. Okay. And to show you that in action, actually, I have created another Cosmos account here. If we look here at the virtual network section, here my service endpoint has already been configured, right? And by the way, the reason I've done that, the reason why I have kind of pre-provisioned my resources is that because of the distributed nature of Cosmos DB, any update to network security takes some time to take effect. Okay? What we are publicly documenting is that any update to the firewall and the VNet section can take up to 15 minutes to propagate and take effect. In reality, it's much it's much faster than that. But you have to expect that it will take some time until everything takes effect. And I didn't want our viewers to just sit tightly until everything propagates.
Like here, let's sit here and watch paint dry as we provision our account, right?
Absolutely,
or
absolutely.
Create our network connection. So yeah.
Yep. So here I have my Cosmos 2 account that's running in that has been kind of attached to my VNet through a service endpoint. Okay. Now here I am in a VM running in the same VNet. Okay. So here the context here is that I am really running in that VM that has been attached to my Cosmos DB account through a service endpoint, and I have just a very basic sample JavaScript function that just tries to fetch all the items I have in a specific container from my database. Now, if I run that code here, so if I run that code with Cosmos 2 as being the connection string I want to use, well, obviously it works, right? Because I am in the VNet and I am completely allowed to access my Cosmos DB account. Now, if I try to run the same app from my desktop, okay, so here it's exactly the same app, but this is running, from my laptop and obviously outside of the VNet. This is, basically the computer I'm sitting in front of. So if I try to do the same here, as you can see, the request has been blocked, right? Very actively with a 403 code. This is forbidden because basically it has been rejected at the IP level, right? And although I didn't have to explicitly allow the IP of my VM, that IP sitting in the VNet make it possible for the VM to connect to my Cosmos DB account. It's not the case here. I'm outside of the VNet, so this is getting actively blocked. Okay. One thing to keep in mind is that when you use service endpoints, okay, in the context that I'm showing here, you are still accessing your Cosmos DB account through its public IP address. Okay, yeah. And we can see that now if I go back to my VM, okay, and I do an NS lookup on so what's the name again? I think. Whoops. I have a little connection issue with my VM. Let's see. Let reconnect. Okay, here we go. So I was doing a NS lookup on my account. I believe the name is Cosmos. Oh.
Oh wait. Some network security getting in the way there, it looks like.
Yeah, yes. Obviously, my connection with you guys is still good. Azure, Azure.com. Okay, so if I did an NS lookup, to that Cosmos DB account, to the FQDN, the fully qualified domain name of the Cosmos DB account I'm connecting to, and the address, this is a public IP address, right? This really looks like an internet address, meaning that even though I am running in my VNet, and even though I am connecting to my Cosmos DB account through a service endpoint, we still go through a public DNS. Okay? So when the Cosmos DB client tries to resolve that FQDN, it hits the public DNS. What I get in return is the public IP address of the Cosmos DB account. And so eventually, I still connect to that account through a public IP address. Okay? Back to my fancy slides. What that means that in terms of the security boundaries you can put around your VNet, well, you still need to have some access to the outside, right? Although I have that service endpoint that guarantees that anything in my VNet and only resources running on my VNet are allowed to connect to my Cosmos DB account, well, I'm still connecting to something that is outside of the VNet. Okay, I'm still connecting to, well, the public internet in that case. And in some situations, this can be seen as a concern. The main concern around that kind of a use case is data exfiltration. Right?
Yeah.
We have customers who are very concerned about, the possibility of having, let's say, rogue employees who connect to their Cosmos DB accounts, production accounts, and somehow are able to suck out all the data, all the production data from, their businesses and copy that data somewhere else on the internet. Which unfortunately, happens. But this is not necessarily a valid concern for any Cosmos DB user, but there are specific industries and verticals that should be cautious about that. And so it's to address those kind of use cases that we have introduced. I think it's like a little more than a year ago. That other way to connect between a VNet and a Cosmos DB account, and that other way is private endpoints. And the main difference between service endpoints and private endpoints is that a private endpoint exposes the Cosmos DB account through IP addresses that are private and local to the VNet. Okay, and here the fancy animation is going to show you that actually that private endpoint brings the Cosmos DB account within the scope of the VNet. Okay, so it's and this is something we are going to see in just a moment. So from an application standpoint, whenever you access that Cosmos DB account, although that account itself is not really running in the VNet itself, we are a PaaS service, so we are a shared service, but that endpoint is kind of mapped through IP address that are local, and so that means that
is that IP address then is it exposed in its own subnet then within the VNet?
Yeah, absolutely. Okay. Yeah. Right. And what that enables is that in terms of security boundaries, you can completely shut off your VNet from the outside, right? And you can make sure that any connection to the outside and any connection to the internet can be actively rejected, because all you have to connect to is exposed locally or privately within the context of the VNet.
So you could, interesting. I mean, it lets you use other features in Azure networking, such as being able to do your custom routing or other NSGs.
Absolutely.
In there. So that's quite interesting. I mean, you could at that point then really strictly control anything going in or out, the direction it can go, what it can connect to, that sort of thing.
We have customers that use private endpoints in conjunction with ExpressRoute, for example, to connect a VNet to some on-prem resources. But by leveraging private endpoints, they also can keep a very tight security configuration of their VNet as well.
Yeah, and the guys that run networks for big companies tend to be they don't want to keep really tight control of that space, right? So
absolutely. Configuring private endpoints is not much more complicated. Okay, if I wanted to add a private endpoint to my Cosmos DB account, again, I can do it directly from the portal. You click on private endpoint connections. You need to create a new private endpoint. Okay, so this is really going to create a new resource in your resource tree and in your resource group. That private endpoint will be identified as a specific new Azure resource. And this is basically where you give it a name. You select which. Actually, let's go through the wizard here. So you give it a name. You can select where you want that private endpoint to live. Then you go to the resource. The resource being the Cosmos DB account that you want to map. So here I would say I want to select Microsoft. Where is it?
I think it's Microsoft.azure.documentdb.
Yeah. Yeah, here it is. Cosmos DB account. Thanks, Mark.
Yep. I'm the RP guy, so I know where that resource sits. So.
Absolutely. This is how you would select which Cosmos DB account you want to map. So I'm going just to select one randomly here. Then you can also target what's called a sub-resource, and basically this is going to be which API you want that private endpoint to map. Okay, and you might be surprised, asking yourself, why do I have to choose that? Isn't any account just single API? It is, except that in some specific situation, like for example, if you have created a Gremlin account, okay, in order to use Cosmos DB as a graph database, you can actually access that account through either the Gremlin endpoint or the SQL API endpoints, right? So because we let you use your Gremlin account also as a document database, and so that's one of the rare situations where you may want to choose, whether I mean, if that account was a Gremlin account, here I would have two choices, either Gremlin or SQL.
Interesting.
Yeah.
So that's why we have the sub-resource in there, is because we expose two endpoints for things like Gremlin.
That's right. And what that means also, obviously, is that if I wanted to map both the Gremlin and SQL API endpoints of my Gremlin account through private endpoints, I would need to create two separate private endpoint instances, okay? Because each private endpoint maps one specific API of the account. Okay, so here I'm choosing the Cosmos DB account I want to map. Next, in the configuration, I'm going to check, obviously, which VNet and which subnet I want that private endpoint to be connected to. And then that's another very interesting part, which is the private DNS integration. As I mentioned before, when you create private endpoints, your Cosmos DB accounts ends up being exposed in your VNet through private IP addresses. Okay? But then you have to think, how am I going to resolve my FQDN? How am I going to resolve my account.documents@azure.com to those private IP addresses that are only living in the scope of my virtual network? And that's why in situations where you are using private endpoints, you need to think about some kind of private DNS running in your VNet that will resolve the account name and the actual connection string to those new private IP addresses that we are going to map.
Are you creating a new CNAME entry for this and then giving it a new custom name, or you're just basically mapping the existing CNAME to a new IP address?
So what the option that we present by default here is to integrate with another Azure networking feature, which is called the private DNS zones.
Mm-hmm.
Okay, and so what that thing does is that it's going to run a private DNS only in your VNet, and by doing that, it will automatically map all the CNAMEs to the local IP addresses. Okay, this is done automatically, basically. And to be honest, this is the option that I usually recommend, because it just works, right? You just have to flip that switch and say, I want my local IP addresses to be mapped back to the FQDN of my Cosmos DB account, and this is done automatically for you. Customers who prefer to run their own private DNSs, then they would need to add that mapping manually, right? And Private Link and Private Endpoints, they provide all the APIs for you to query in order to fetch that mapping and to actually do the configuration of your private DNS. But in situations where you don't want any more moving parts and more things to do yourself, going with the private DNS zone is definitely the way to go.
Yeah, makes sense. Definitely.
Yeah. That's pretty much it. Then, as usual, you can add tags to your resource, review and create, and that would create your private endpoint. I also have another account that is already pre-configured with
already in the oven, ready to go.
Yes, absolutely. Absolutely. More work to do before, but then it makes the whole session a bit more interesting to follow. So that's my Cosmos 3 account where I already have a private endpoint configured. So we can look the details of that private endpoint. Again, it is an Azure resource by itself. Okay, so here I landed in the resource blade of the private endpoint itself. This is where you can see the DNS configuration. I can see that I'm using private DNS. I do have maybe a little UI glitch here. Oh no, it's not actually. Basically, that Cosmos DB account has been exposed to my virtual network through 2 IP addresses. As you can see, those are really private IP addresses, not public ones, and each of those addresses is mapped back to the FQDN of my account. Okay. What's interesting to know is that when your Cosmos DB account is deployed in N regions, we always map N+1 FQDNs because that account is just deployed in WestUS2. So 2 FQDNs are exposed: the regional one, where WestUS2 is appended to the account name, and the global one. Okay. If I were to actually go back to my Cosmos DB account, add a second region, and maybe deploy that account to, let's say, EastUS2, I would end up with 3 entries in my private DNS, right? Because I would also have the -EastUS2 option here. But again, the magic that comes with private DNS integration is that this is all done automatically, right? You don't have to think that you need to amend your private DNS configuration when you add or remove regions. This is done automatically for you. Obviously, the same happens if I remove a region. The corresponding entries in my DNS are going to be removed.
So does it get a little complicated when customers have different VNets or subnets in different regions for their applications?
It's not, because eventually the way you use Cosmos DB from a client perspective is exactly the same, right? You don't have to think about those private IPs. The mapping is being done automatically by those private DNS zones and the private DNS integration. When you initialize your Cosmos DB account, you still initialize it with a connection string that references the FQDN.
Yeah.
Right? And so, eventually, I think the integration story is very compelling for our customers, because in a few clicks, the private endpoint is created and it's automatically mapped back. The FQDN is mapped back in that VNet through that private DNS. From a client perspective, it's exactly the same. And actually, that's a good segue, Mark. I can switch back to my VM if I haven't lost the connection again. No, I'm still good. And let me run exactly the same test as before, but on that Cosmos 3 instance that is connected to that same VNet, but through a private endpoint. And as expected, that just works, right? And which means that I didn't need to change anything in my application. I can still use the same connection string. All the magic happens at the networking level. Now, if I did the NS lookup again to see, that Cosmos 3, what is it mapped to? As you would expect, we have already seen the answer in the previous screen, but this is mapped to that 10.1.0.5 IP. That is an IP that is local to my VNet. Okay.
Yeah, cool.
Yeah.
So again, you need both of those IP addresses because the clients always resolve to the regional endpoint, isn't that?
Right.
Is that why we have both of them in there?
Yeah. So what happens when the Cosmos DB SDK connects is that it's always going to start with the global one in order to fetch initial configuration, and then depending on your configuration, it will switch back to the regional endpoint. Yeah. But all of them need to be available, even for HA and failover reasons, right? Sometimes I also do have private endpoints users asking me, how does it work when there is, let's say, regional issues and my client needs to fail over? Again, this is going to happen completely transparently, because if I had 2 regions here, actually I should have done that for the sake of the demonstration. I would have 2 different local IP addresses mapped to those 2 different regional endpoints. And so if WestUS2 for some reason became unavailable, my Cosmos DB client would fail over the other one transparently, just as it would do outside of the private endpoint.
I was going to ask that question. So interesting. That's really super to hear, because it's, to me, at first I'm like, yeah, how is that going to happen, or how's that going to work? Are you going to lose connectivity? But what you're saying is no, it'll just continue to work. So
absolutely, and all the failover logic that is embedded in our SDKs works exactly the same, because again, the SDK, just like the rest of the stack, doesn't know that they are working from a private endpoint, right? Yeah. Eventually, what that means is that they are going through some different IP addresses, but the SDK doesn't care about that. As long as the FQDN resolves to the right to addresses that actually map back to the service, everything just works.
Yeah, great. That's so cool.
It is, and we're actually very happy to to close that loop, other services introduced private endpoints a bit before Cosmos DB. We launched that thing. I think it was early next year.
Ignite last year, wasn't it? Or was
I think so. Yeah. Early last year, and we have seen very satisfying adoption, especially from our big enterprise customers who are kind of lacking that ability to actually lock down their VNets to only local IP addresses. And so this closed the loop in a very nice way.
Cool.
So talking about network security, this is really pretty much it. To summarize, the first thing that you can do is to enable selected networks in your Cosmos DB account, and from there you can either input some IP addresses that you want to be able to connect to your Cosmos DB account, and anything else will be denied. Or you can start connecting to specific virtual networks through those endpoints. Service endpoints here, private endpoints there. And by the way, what I also wanted to mention is that those things are not exclusive, right? What happens by default, if you create a service endpoint, what happens by default is that only resources running in the corresponding VNet will be allowed to connect to your Cosmos DB account. Anything else will be rejected. But you can then also, on top of that, add some IP addresses here, right? Our IP Firewall complements those endpoints, and so you can mix and match, and you can totally create endpoints and also add entries in the IP Firewall, and all those things will just work together.
Got it. So that's good because you can basically kind of test as you prepare your deployments for production, essentially.
Yes.
Add the VNets, the subnets, all the other features in there, and then still continue to connect via your endpoint or your IP.
Absolutely. Yeah. And that's also a good point, Mark. And not surprised because you are the control plane guy. But everything that I just showed today can be scripted, automated through either ARM templates or your favorite control plane tools. So if your requirement is to automate the deployment of, let's say, a new production account, but also at the same time and within the same deployment, add firewall rules or configure endpoints between a VNet and your Cosmos DB account, this can be all done within the scope of the same ARM template.
Yeah, in fact, I think you wrote the ARM template sample up on the quick start gallery that deploys a VNet, a subnet, and a Cosmos account, and then configures it all together, right?
That's right.
Together. So yeah, that's a very cool little sample you got there. So, and you got, I think, lots of other Bash and PowerShell scripts also in the doc. So if people want to script that out, they can for sure. So
that's correct. Yeah. Those ARM templates, they need to follow that sequence because as usual, some resources depend on the existence of other resources. So you have to kind of sequence your deployment within the same template. So you start with the Cosmos DB account, and you can add the VNet, and then once those things exist, you can create the points between them. But totally doable. I'm
in the process of adding bicep support to all of our ARM templates right now. Yeah. I got started a couple of weeks ago. I'm still, a bunch of the stuff is still in PRs. I got distracted and pulled off on something else. But that's something I'm hoping to have all those pushed out. So they'll all be in the same repos as the ARM templates, and they'll have equivalent bicep support in there as well. So so look out for that, folks, in the next couple of weeks. I'm also going to take a swipe at writing a bunch of Terraform scripts as well. See if I can help increase the support on that. It seems like increasingly people are using Terraform to provision and manage their Cosmos accounts. So I'd rather just create a bunch of samples rather than ask or answer questions I get all the time. So yeah, this is great, Thomas.
Yeah, that's all I had. And just also to reiterate, again, the network security is going to be the foundation of your security posture. Doesn't mean that once you have network security enabled, it's the end of the journey. Then you need to think about further access control. And the best way to tackle better access control is to look back at the episode you and me did 2 to 3 weeks back, where we introduced the new role-based access control that is available on Cosmos DB. So those things are kind of orthogonal, but they complement each other very well for you to make sure that you have the best security posture.
Yeah, really first-class enterprise level security features now with Cosmos, where we've got obviously the network security aspects of this that have come on in the last year or two, and then support for Azure AD and RBAC in there. Yeah, it's been a great journey, I guess, watching all these great features come. I mean, and customers have been asking for it, right? We don't just create it for nothing.
Right, of course. Yeah. We are filling some gaps, but we are in a great state right now. I mean, over the past year, we have introduced things like customer managed keys that let our customers control the encryption at rest of their data with keys that they manage from Azure Key Vault. RBAC was another, big pillar for us to tackle. We are right now introducing managed identities for Cosmos DB. System assigned identity is already supported. We are in the process of deploying user assigned identity as well. So yeah, we are in a great state right now, and the journey is not finished. As I hope,
more stuff coming. Right,
there's stuff coming. There's stuff coming next week
too, right? To talk about some of that, right? So
absolutely.
You're a busy guy with all these security features coming around, right?
Absolutely, yeah. Anyone who is passionate about security and how to secure databases, you should be thrilled by what we are going to announce next week. Another big pillar we are tackling with something I will not mention today, but in just five days from now you should know.
That's it. You got to tune in next week, folks, or you just definitely join or register for Build next week, and then you can hear all the announcements and see all the action, and then come back and join us here next week as well. We're going to have Thomas back, and we got Tim, who's been on the show. Deb was on our very first episode talking about notebooks. Stephanie will be back. She was just on last week talking about our new Linux emulator. Is that it? Oh, and Saranya. She's also been on the show, and she's going to talk about something very exciting. I'm not going to let the cat out of the bag.
another big one.
It's another big one. Big. So yeah. Well, great, Thomas. Well, thanks so much for joining us again this week. It's great having you on, and thanks for showing. This is just some great stuff for Cosmos and being able to secure your database. And and like I said at the top of the show, when you got a database that's on the internet, you need to have good, solid ways to keep it secure for sure. So, okay, well, that's it for this week, folks. Thanks for joining us. And like I said, next week we're going to have a whole bunch of the team on, and we're going to recap all of the announcements that we are going to make at Build this next week. So come back and join us then. So Thomas, thanks again. Good to see you.
Yep. Thank you, Mark.
And we'll see you again next week.
Looking forward to that.
Okay. All right. Bye, everybody.
Bye.